And so if I drop an altitude to that base, I've created a right triangle here, and I can use right triangle trig, and the sine of 30 degrees is h over 10. And then the height I can multiply by 10 and go back to the unit circle at 30 degrees. The sine is 1/2. That's why I picked it, so it would be an easy one to evaluate. And the height is 5. And that height is 5. And when that small side is between the height and the big side, then there are 2 triangles. So when, in this case, the height is 5, the shorter size is 6, and the longer is 10, there's going to be 2 triangles. And in the notes, we'll talk about how we find the 2 triangles. We expect that there are 2 triangles. If the height is equal to the small side, then there is only 1 triangle. And when the small side is less than the height, there are no triangles. Another thing that I forgot to start from the beginning is that angle must be acute. The angle must be acute. So the angle has to be between 0 degrees and 90 degrees. You never get 2 triangles when the angle is obtuse. You never get 2 triangles when the angle is obtuse. And what happens is that 6 can come and swing, and it could be over here. And so it's kind of like it's on a swinging arm with center of the circle. Okay, I can't draw a circle. The center of the circle here, and the radius is 6. And if it's just in between the 5 and the 10, it can swing in, and it creates this second triangle, and where this angle is obtuse. But this angle remains 30 degrees, this is 10, and this is 6. So you have just the right amount of room to swing it in and create that second triangle. So anyway, that's what's kind of happening. There's a video for that, a YouTube video for you to look at to see that. And so this summary right here is about little side, big side, and then an angle of some sort. It could be obtuse or acute. And so the first 4 all are about the angle is acute. And by the way, the height is always b times sine of a. But when we do that, the angle and the side are the sides adjacent to the angle. So if the angle is acute and the opposite side is less than h, and again, how do you find h? B sine of a, there will be no triangle. And when you find out that that opposite side is equal to b times the sine of a, there is 1 triangle, and it's when it actually ends up being the right triangle. In the setup, if A is greater than B, so instead that would be big side, little side angle. Anytime, even though the angle is acute, if the side opposite is larger than the adjacent side, there will just be 1 triangle. There will be a triangle, and there will be 1 triangle. And then this is what I talked about in that beginning, is if H happens to be, which is your B sine of A, is between A and B, there will be 2 triangles. And then when the angle is obtuse, you only get 2 things that happen. You get one triangle or no triangles. The thing about when you get no triangles, you get to something, say, where you're trying to take the inverse sine of a value that's bigger than 1. Or you get a value that's less than a -1, and that is not possible. And so when you do the inverse sine, you get an error message. So by default, when there's none, you will get to an impossible calculation and you will know to stop. The issue is really this one right here, where if you can solve the first triangle, and if you don't know to look for the second, you will miss it completely. So that's what this lesson's about. All right, for accuracy, round to 4, I usually use 5. And then only in the answer box, round to 2 decimals. So everything before you get to the answer box, unless it's your final thing you calculate, should be to, I would say, 5 decimals. All right, so triangle ABC. And little a is 24, little b is 15, and angle A is 26 degrees. And right here, this is big side, little side angle. The side opposite the acute angle is larger than the adjacent side. There will only be one triangle, and there will be one triangle. So it's this case right here where A opposite the angle is bigger than the adjacent. So it's, I mean, we didn't, A, B, and C can kind of be interchanged. It's the idea the opposite side is bigger than the adjacent and the angle's acute. So there will be a triangle and there will only be one. And so then we're just going to go ahead and set up the law of sines. We have 24 is to the sine of 26 degrees, as 15 is to the sine of angle B. And as I mentioned in notes yesterday, when you're trying to find the angle, it's easier if we use this flipped. It's a property of proportions. They are equivalent. And then I need 15 times the sine of 26 degrees, all over 24. And that's the sine of B. But then I need to take the inverse sine of that value. And the inverse sine of the sine of B gets you the measure of angle B. And so if we go to calculating, we have the inverse sine. I'm going to just edit. We had 15 in here, 26 all over 24. And so the measure of angle B, approximately 15.90136. And that is degrees. And so I don't have to worry about a second triangle, but you have to know your stuff. Acute angle, possibility. Side-side angle, a possibility, but opposite side's bigger than adjacent to the angle. Only one triangle. So that means I can find the measure of angle C by taking 180 degrees minus the 26 plus this. And it will be approximated. And for angle C, it comes out 138.09865. And now we can find little c, and I would go back to the 24, 24 is to the sine of 26 degrees, as little c is to the sine of 138.09865. And, keep on putting the degree symbols on what's degrees. And so C is approximately 24 times the sine of that angle. All over the sine of 26 degrees. And so if we clear it all, and we just have 24 sine 138.05. No, it's not that. 0.9865 divided by sine. Oh, that's great. I didn't get a decimal in there. There we go. That's better. Can't have a negative. And so that is the last thing that we have to find. So if you round that to 3 places, that's just fine. And then I want your answer box. So the first thing we found is measure of angle B. 15.901 degrees to 3 decimal places. Then we found the measure of angle C, and 138.099, and little c, 36.564. And I guess we have inches on little c. So it just takes time and some, being careful, and it's a little bit of repetition, a little bit of typing to get the answers. But the formula, hopefully you already have got that down, right? All right, so for the next one, show that there's no triangle with this, so we have A, B, and C. And A is 78 degrees. This is 7, and this is 14. Now, there's 2 ways that you can show me this. You can show me that the height is 14 times the sine of, it's always the adjacent side times the sine of 78. So 14 sine of 78. The height is this 13.694. And since 7 is less than the height, it can't swing in and hit and create a second triangle. However, you'll find this out by doing the equation, and that's how I've always done it. If I set 7 is to 78, as 14 is to the sine of B, and that means the sine of B is 14 times the sine of 78 degrees all over 7. I just did 2 steps in one. And so to find the measure of angle B, you need the inverse sine of this. And you can do this to show that it doesn't work. And so if I clear this and I try and do the inverse sine of 14 sine 78 divided by 7, it tells me it's undefined. So did I make an error in setting it up? I don't want you to just say that it's undefined. I want you to actually get rid of this and evaluate. It's supposed to be divided by 7. I lost the division. The reason why it's not working is this is not possible. This is not in the domain of an inverse sine. Sine's range goes from -1 to 1. So the domain of the inverse is -1 to 1. There is no angle whose sine is bigger than 1 or less than -1. And so this is not possible. And that's what I was talking about. You don't have to worry about where there are no triangles because you get to an impossible calculation because that input is not in the domain of the inverse. So it will just stop you from finding a triangle. So that is not the problem. It's knowing when to expect two triangles. And so let's move to the back page. All right, find two triangles. Now here we're telling you it. But so what's the setup? This is a little case, bigger case angle. It is going the side opposite an acute angle is smaller than the adjacent. And I can check if I take the height is 14 sine of 40 degrees. It's always the adjacent side times the sine of 40. So if I go back to Desmos and calculate that, or attempt to. So if I do 14 sine of 40, I'm getting 8.999. And so the little side is between the height and the big side. 12 is less than 8.999 is less than 14. So I know there is two triangles. So there's the first one. The second one is going to be where that side of 12 swings in and creates this obtuse angle. And I'm going to call this A prime, B prime, and C prime. And so now how we get C prime is very important. There is only one angle we can calculate first. So we do that. And so we're calculating an angle, so let's save myself the time of flipping it. Sine of 40 is to 12, as sine of C is to 14. And so 14 times the sine of 40 degrees over 12 is the sine of C. And the measure of angle C is the inverse sine of 14 sine of 40 degrees over 12. By the way, your calculators have storage features where you can save a value and recall it, where you don't, you write the numbers on your paper, but you could recall it on your calculator. But I'm going to let you find that out. You can watch a YouTube video. Maybe later individually we can sort it out, but I'm not doing that in class because we have different calculators. And that's a handy thing to be able to store. So anyway, so we go and we clear and we have the inverse sine of 14 sine 40 divided by 12. And so there's my measure of angle C. Don't get rid of that quite yet. And I'm going to go to 5 decimal places. I also believe that is the recommendation in AP Calculus, is to go to 5 decimals and then round to 3 decimal places unless otherwise specified. So you need extra digits to make your end answer valid. Anyway, so there's my angle. Here is the learning. Write it on your paper in bold. You always can only find one angle. And then in your second triangle, to find the measure of angle C prime, it is the supplement of this first angle you found. So if I take 180 minus that value, then I'm getting the 131.41665 degrees. And that's what goes right up here. So this is in my way, so there we go. When there are 2 triangles, no. Oh well. I don't know what I just did. Okay, it's still recording. This is good. When there are 2 triangles, find only angle you can find. Then use the supplement for the second triangle. When there are 2 triangles, find the only angle you can find. There is only one thing you can find in that given triangle. Then immediately after calculating it, go over to your second triangle and find the supplement. And now you have 2 triangles to solve in the manner that you solved the 2 that we just did before. You just keep on going. And so for here, on the first triangle, you can find the measure of angle B by taking 180 minus the 40 degrees plus the 48.58335. And that angle B is 91.4166 5. And then set up the proportion. You need to find little b. So 12 is to the sine of 40 degrees, as little b is to the sine of 91.41665. And so then b becomes 12 times the sine of 91.41665 all over the sine of 40 degrees. It's just repetitive, and there's just a lot of numbers to calculate out. And so for little b, that's all we need it for, so it's 18.663. And there are no units. And so then a box for the first triangle, you found angle C to be 48.583 degrees. You found the measure of angle B to be 91.417 degrees, and little b to be 18.663. And there are no units. And the second triangle, for the second triangle, you just go through the same thing. You need the measure of angle B prime, and that's going to be 180 minus the 40 degrees plus the 131. And that is 8.58335. Right there, if for some reason you got a negative angle, that means you either messed up with the math or it actually didn't have a second triangle. And then I'm just going to say and etc. You know, you're going to set up to find little b by doing 12 is to the sine of 40 degrees, as b is to that sine of 8.58335 degrees, and continue to solve. And do another box with all those in there. And so in example 4, let's set it up. I don't think we need to do all of it. I'd rather give you a little more time on your homework. A is 30 degrees, opposite is 6, and C is 10. Again, it's short side, big side, angle, and the angle's acute. If the angle is obtuse, there will only be one triangle. If the original angle they give you, even though it's side-side angle, it will only be one triangle or no triangles. Just start solving it, and you'll get to that error message, undefined, when you try to do the inverse sine if there's no triangle, and you can say no triangle. But you don't have to worry about a second triangle ever if the first angle is obtuse. It's only when it's acute. So anyways, in terms of the adjacent side times the sine of 30, oh, that was the same, that's your height. And that's 10 times 1/2, and the height is 5. And so since the height is smaller than the little side is smaller than the big side, 5 is less than 6 is less than 10. That looks like a 5. There are two triangles. So there will only be one angle to find. Since we're going to find an angle, I'm going to put the sine on top. Sine of 30 is to 6, as the sine of C is to 10. And so you get 10 sine of 30 degrees is to 6 is the sine of C. So the measure of angle C is the inverse sine of this. And C comes out to that to 5 decimal places. So then you want to stop right there and think about A prime, B prime, C prime. And the measure of angle C prime is the supplement. And that comes out to 123.55731. And that's going to be this angle right here. This stays 30, this stays 10, and this stays 6. And then you just continue to solve for all the pieces, as though they are two different problems. And for this one, if you check it out, 123.557, if you want to practice, to see if you've got it, measure of angle B prime, 26.443, and little b prime, and over on the other one, measure of angle C, 56.443, measure of angle B, and then little b is 11.977. And there were no units on it, so we'll just leave it like that. And that's it.